Okay, this section is about another rule called the chain rule, how to take derivatives. And just for a review, if we have two functions composed with one another, it looks like that. Suppose f of t is sine t, and g of x is 2x, and let this be equal to t. So if we compose or substitute in g into f, which is what's happening here, then f of t is going to be f of g of x, because that's what we said t was equal to, and that's f of 2x, so we're going to substitute 2x into, that's what f stands for. F says you take your variable and do sine of it, so this is going to be sine of 2x. So basically what we're doing is just taking this and substituting, taking g and substituting it into f. So this is called a composition of two functions. It's composed of a sine function and a 2x function. And let's go back here and let's call this v. So if we want to take the derivative of this, if we have v equal to f of t, that means v is a function of t. So we have dv dt to be the derivative, and the derivative of our function is the derivative of sine, which is cosine. And then we have t equal g of x, so we say t is a function of x. You see how these two functions are building on one another. And dt dx is then d dx of 2x. Derivative of 2x is 2. So if we want the derivative of the two functions composed, then we can say that this is dv dt times dt dx, and it's like the dt's will drop out. That's cosine t times 2, but we want this to be a function of x, so we said t was equal to 2x, so the answer to this is cosine 2x times 2. That's the derivative of sine 2x. Now let's go about this and see what this is. This happened to be dv dt, which is f prime of t, and 2 was g prime of x, but f prime of t was f prime of g of x times g prime of x. So I'm putting it in terms of x. This is what we have. So the chain rule, again, we're not going to prove this. This is not a proof. The chain rule says, 1, take the derivative of the outside function, which is f, leave the inside function alone, leave it there, and then take derivative of inside function and multiply. Well, how does this apply? We just saw how this is applied. This right here is f prime g of x. G of x is the 2x, and that cosines the derivative of sine. So we left the 2x alone, and the 2 was the derivative of 2x. And this leads us to the superpower rule. This is how we really use the chain rule, which is 4 steps. If you have a function raised to a power that you want to take the derivative of, then you bring the power down, leave f alone, subtract 1 from the exponent. That's the power rule. But then you have to come back and take the derivative of the function. So this has 4 steps. Bring the power down in front, leave the function alone, the f we leave alone, we subtract 1 from the exponent, and then we take the derivative of the function and multiply it. And multiply. Alright, so let's see how we use this. Let's take the derivative of 2x squared plus 1 to the 7th power. Bring the power down. Leave the inside alone. Okay, this is the function f. We're going to leave that alone. Subtract 1. And multiply it by the derivative of the inside function, which is 4x. Derivative of 1 is 0. So, power down, function, inside function left alone, subtract 1, derivative of inside function. All right, we'll look at some of the example homework problems, and let's see, maybe I'll try a few more. Let's try this one with the square root. Okay, 2 is a constant, so 2 is just going to stay out in front. You have to rewrite the square root to the 1/2 power. So just for a reminder, the inside power is the numerator and the outside radical, the index, is the denominator. Okay, so on this we leave the 2 alone, we bring the power down, we leave the inside alone, we subtract 1, 1/2 minus 1 is negative 1/2, and we come back and take the derivative of the inside. Derivative of 5 is 0. So let's clean this up a little bit. Those are going to divide out. We have 3x squared in the numerator. A negative exponent puts the square root into the denominator, and that would be our final answer. So the negative exponent puts the power in the denominator, and the 1/2 power represents square root. And the quotient rule and product rule will apply here also. But you can look at some of the example homework problems and we'll see that. Now we could use a quotient rule here, but since we have a constant in the numerator, the best thing to do, the trick here, is to rewrite this to the negative power. So I would always do that You don't have to, but if you use the quotient rule, it's a lot longer. So when I take the derivative of this, I bring the power down, leave the inside alone, subtract 1, come back, take the derivative of the inside. Derivative of 3 is 0, negative x. The derivative is negative 1. So the answer is going to be 10 over 3 minus x to the 11th. Remember, the negative exponent puts it in the denominator. And let's try one more. Sine squared x. I would rewrite that as sine x squared. And bring the power down, leave the inside alone, subtract 1, so 2 minus 1 is 1, come back, take the derivative of the inside, derivative of sine is cosine. If you notice, that's a double angle formula for sine, so that's the same as sine 2x. Double angle formula. So I brought the power down, left the inside alone, subtracted 1, and came back and took the derivative of the inside, which is cosine. Derivative of sine is cosine. And let's do cosine of pi over 2x. The derivative of that, starting on the outside, the derivative of cosine is minus sine. Leave the inside alone. Come back, take the derivative of the inside. Pi over 2 is a constant, so that's just pi over 2. And that's your answer. So look at some of the homework problems, and you can see more examples of the chain rule.